Hello everyone, welcome to the GATE and PTL lecture course. Today we are going to solve some GATE problems. There is this question in GATE 2019, question number 14. The electric field of an electromagnetic wave is given by 3 sin kz minus omega t in x cap plus 4 cos kz minus omega t in y cap. Now we have two components here. One is the Ex, which is the x cap component. Another one is Ey, which is in y cap direction. Now the wave is, we have to answer whether the wave is a linearly polarized, elliptically polarized, or with some angle. If it is linearly polarized, what is the angle? And if it is elliptically polarized, is whether it is moving clockwise direction or it is in counterclockwise direction. So we will solve the problem exactly the same way as we did for the circular polarization. So we are given an electric field with 3 sin kx minus omega t and cos kz minus omega t. Now you see the Ex and Ey component. They have a phase difference of pi by 2. One component is cosine and another is sine. So there will be no chance that it will be linearly polarized. For a linear polarization, phase should not be a multiple of pi by 2. Either it will be 0 or a multiple of pi. So it is not a linear polarization because for 0 and 1 pi case, in that case, their both component are cosine. So for linear polarization, both component has to be cosine. Circular polarization, amplitude has to be same. So amplitude is different. So it is also not a circular polarization. Now we have elliptical polarization. But there are two cases possible. Either it move in counterclockwise or clockwise directions. Now to check this, we just put z equals to 0 in this and we are left with Ex component which is minus 3 sin omega t and Ey component 4 cos omega t. Now we check with at omega t equals to 0, what is the condition? At omega t, Ex is 0, only Ey is equals to 4. So at omega t, we have this component Ey survive. As the time increases, omega t become pi by 2, Ex will become minus 3 and Ey will become 0. That is, it is moving in this direction and it is to minus 3 with time. So with time, it is moving in this direction. So if you look at this direction, this is counterclockwise direction. So the right answer is D. It is an electrically polarized light in counterclockwise direction when seen towards the traveling towards the observer. If you are standing, minus z direction, which is away from the observer, then you are just like you are looking at this clock from behind and you see opposite direction. So you will need take care of the question in the question where it is asked towards the observer or away from the observer.